Good afternoon, everyone. Today we're going to do a video speaking about more general concepts in problem solving. So here's our question. We want to find the sum of the digits in 10 to the power of 2021 minus 2021 itself. Now, when we look at a problem like this, I don't know about you guys, but the first time I looked at this problem, I really had no idea where to start. And that's oftentimes in math, the situation we find ourselves in. When we get to the end of assessments, usually when we get to the harder problems, we often don't know where to start. That's precisely why those are the problems that get us to those really, really high marks. And those are the problems that really test our deep understanding of the topics that we're studying. Are we able to use the skills that we've learned and solve novel problems? Not problems that we've never seen a template for, problems that we have to kind of create a template for ourselves. And so I think this is really where our understanding of the mathematics that we're studying are put to the test. For an example like this, we want to look for the digits in the expansion of 10 to the power of 2021 minus 2021. So I'm going to start off and I'm going to repeat this several times, I'm sure, over the course of the video. But my first recommendation, whenever you're solving a problem that you don't immediately know where to start with, is just write down anything that comes to mind that you think could be relevant. There is nothing that I can emphasize more than the idea of simply writing stuff down that you think might be relevant, because writing something down gets your brain in an active mode. It puts your brain into a state of working, and once you start writing stuff down, things usually start to piece together. Because if you don't write anything down, you're not going to get anywhere. You have no idea how to approach this. Writing something down, even if it turns out to be unimportant, but in the end, if it gets you to somewhere that is useful in the end, then it has served its purpose. And this is something my students, when we're not used to doing this, it's something that looks so daunting at the start, but I can't emphasize it enough. If you don't know where to start, just write anything down. Write anything you think might be useful, and that'll get your brain into an active mode, okay? So for something like this, let's think about what the expansion of 10 to the 2021 is. So 10 to the 2021 means 10 times itself 2021 times. Now that's going to be 1 with 2021 zeros after it, right? So if we want to check that, 10 squared is 100, 10 cubed is 1000, and so on and so forth. So the exponent on the 10 is simply the number of zeros that follow the 1. So likewise, 10 to the 2021 is 1 followed by 2021 zeros, right? I know there's not a apostrophe there, but to really clearly demonstrate what I'm trying to show, I'm gonna write it like that. So here's where we start off. Now, if we subtract 2021, that's not going to affect, in some sense, it's not going to affect really the start of this number. It's going to affect the tail end when we're dealing with the units, the tens, the hundreds, the thousands, and then the 10,000s even. And then afterwards, we're going to see a fairly straightforward beginning of that value after we've taken away 2021. And so what I mean by that is, let's start off with something. Let's start with the first power of 10 that's bigger than 2021. So if we have 10 to the power of 4, which we know to be 10,000, then 10 to the power of 4 minus 2021 is 10,000 minus 2021, which is, what is that? That is 7,979, okay? Now, if we look at 10 to the power of 5, which is 100,000, 1 with 5 zeros, then 10 to the power of 5 minus 2021, is 100,000 minus 2021. And if we evaluate this, we get 97,979. Okay, so we had 7979, now we have 97979. It still may be tricky to extend the pattern, right? Oftentimes what we're looking for, this is really kind of a test in some sense of our pattern recognition skills. The tricky thing is, what pattern are we really looking for? In this case, it seems to be clear that we're looking for the pattern of how the end digits of our value is going to be laid out, okay? Now let's look at the next. Let's see, we have 10 to the power 6 minus 20, 21. Well, that's 1 million minus 20, 21. And so what we'll have now is 997,000. That should be a 7, terribly round. 979. Okay, so we went from 7979 to 97979. You might have figured that the next value would have been 7979, but in fact it's 99779. Okay, so again, we have to go a bit further to really gain a sense of how this pattern is going to lay itself out. Let's say we try 10 to the power of 10 minus 2021. Well, we'll have 1 with 10 zeros minus 2021. And if you go ahead and evaluate this value, we're going to get 5 nines, and then we're going to get 97979. Okay? So, it's only the last 5 digits that are really affected. We could even see the last 4 digits. I'm just going to go ahead with the last 5 digits, because that's really when the pattern ends in my the way that I'm thinking about it. And then afterwards, we're just going to see a series of 9s. Okay? And if we continue, you know, if we had 10 to the 20 minus 2021, what we would get is 9. We'd get 59s, and then 97979. And so extending that idea now to the value that we're ultimately trying to compute, 10 to the power 2021 minus 2021 is simply going to be a bunch of 9s finished off with 97979. Okay? Now, if we look at 10 to the power 10, we have 97979, and we have 5 9s before it. So we have 10 digits in total. Okay? 10 to the power 5, we had 5 digits in total. 10 to the power 4, we had 4 digits in total. 10 to the power 6, we have 6 digits in total. And so it would follow suit, naturally, that 10 to the power 2021 minus 21 would give us 2021 digits. The last 5 we know are consistently 97979, which means the first 2016 digits, right? 2021 minus the last 5 digits are all going to be 9s. These are all going to be 9s, every last one of them. And the tail end will be 97979, which we found earlier on. And so now, to finish off our problem, let's do so over here. What we're going to have is the sum of the digits of our value will be, well, we'll have 2016 9s to start off. And so we can have 2016 times 9, because we're looking for the sum of the digits, so we're going to add them all together. And then plus 9 plus 7 plus 9 plus 7 plus 9. And now we can actually evaluate this very quickly. We're going to get 2016 times 9, that is 18,144, and then plus these 5 digits, 9 plus 7 plus 9 plus 7 plus 9. You can go ahead and add those up mentally with a calculator, but you're going to get 41. And finally, putting those all together, we're going to get a sum of 18,185. And there we have it. Okay? Again, this is perfectly random, seemingly unrelated problem to anything we've studied this year. However, it really puts into focus the importance of learning how to solve novel problems. At first, I'm sure this was daunting, if you guys were anything like I was. However, if we simply start writing stuff down, you know, just start thinking first, how does the expansion of 10 to 2021 look like? What happens? We know that 2021 is only going to affect the last few digits. And so how does the tail end of the number look? Then what does that mean for the first section of the number? And then we're just slowly piecing it together and putting different parts where they kind of belong. And again, this is just a problem to emphasize our general problem solving skills, which we don't often get to in school, in solving really novel problems. And so again, write anything down just to get your brain into an active mode rather than a passive mode. write down anything that you think might be relevant and start slowly putting the pieces together, looking for patterns, looking for pieces that might fit. Okay, I hope this was somewhat helpful. I hope you enjoyed it. And if you guys have any requests for future videos or any problems that you might want to see solved on a video, that would be a lot of fun, really cool to see. And thanks for watching.